Yeah, let's do 2.7. This is the exam one review. Linear and absolute value inequalities. This is the last piece. So if you're given, we'll just do each one. Solve and answer as an inequality with reduced fractions. Okay, so I just need to solve for x. The best way to do this is to have x on your left and your constants, your numbers on the right. So I'm going to subtract 27 from both sides. And I'm going to subtract 15x from both sides. This makes this, what, 9x negative greater than or equal to 1. When 28 minus 27 is 1. Okay. Now we're dividing by a 9, a negative 9. So that means my inequality needs to flip. Okay. So solve and answer as an inequality. Well, there's my inequality. Okay. The next one is negative 3. I'm going to rewrite this one. Negative 3 plus 8x is less than 3. 16x minus 1. Let's need to look up. And this one, we're going to solve and answer in interval notation. I need to distribute my 3 first. 3 times 6 is 48. 3 times negative 1 is negative 3. Okay, now I can get my x's on one side, my constants on the other. Again, I'm going to move my x's to the left and my constants to the right. So this becomes negative 40x is less than 0. I don't remember this one. Divide both sides by negative 40. X is less than 0, right? Let me check myself here. Hold on, y'all. Yeah, that's 3 times 16 is 48. Yeah. So negative 3. Negative 3 I added. Yeah. Okay, it's 0. So looking at my number line, here's 0. X is less than 0. So it's all numbers to the left, not including 0. So as an interval notation, negative infinity, left to right, to 0, not including 0. All right, next one. Solve and answer when you distribute that 3. 3 times 9 is 27x. 3 times negative 7 is negative 21. Plus 7 greater than or equal to negative 1 plus 4x. All right, I need my x's on one side. Oh, I need to combine these. So sorry. Negative 21 plus 7, negative 14. Greater than or equal to negative 1 plus 4x. Now we can do this. I'm going to move my 14 to the other side. Move my 4x over here. So I get 23x is greater than or equal to negative 1 plus 14 is 13. Divide both sides by 23. And x is greater than or equal to 13 over 23. We want interval notation. Here's 0. Here's 13 over 23. It is included, and x is greater than. So 13 over 23, comma, infinity. Solve the inequality, graph the solution. Okay, I'm going to leave it as it is. I'm going to add 9 to all 3 sides. And I get, it's negative 11, so 21 minus 9. Well, let's mess that up. Oh, it's 2. Negative 3x less than 10, that's negative 6. And then divide everything by negative 3 because we're dividing everything by negative. That means my inequalities are going to flip. 12 divided by 3 is 4. 6 divided by 3 is 2. Negative divided by negative is positive. I'm going to rewrite this the way it shows less than the smaller number on the left because it just going to make me want to throttle somebody if I don't. What does this look like in terms of number line? 2 is not included, 4 is, and x is all the numbers in between it. So parentheses 2, comma 4, bracket. Okay, next one. Oh, did I need to graph it? Oh, it says graph the solution it can give. Okay, so graph, well, I graphed it up here, but graphing here. So circle, dot, numbers in between. All right, solve and answer in interval notation. When you have an absolute value is less than 7, you set these all up exactly the same. When the absolute value is less than, that means you're going to have negative 7 is less than, whatever that inequality is, 2x minus 3 is less than 7. Okay. And then solve for x. So add 3 to all three sides. Negative 4 less than 2x less than 10. Divide all by 2. Negative 2 less than x less than 5. And put that in interval notation. It's going to be circles and all numbers in between. So negative 2 to 5, not included. Absolute value of 4x plus 5 greater than or equal to negative 4. When you have an absolute value greater than, you set it up the same way every time. 4x plus 5 greater than or equal to 4, exactly as it's written there. And then the next one you're going to write as 4x plus 5 is less than or equal to negative 4. Okay, these are going to be going away from each other. We're going to be subtracting 5 from both sides. Divide both sides by 4. So x is greater than or equal to negative 1/4. Subtract 5 from both sides. Divide both sides by 4. X is less than or equal to negative 9/4. Number 1. So we've got negative 9/4. We've got negative 1/4 and zeros here. Notice x is greater than or equal to. And it's going this way. X is less than or equal to. So it's going this way. So negative infinity to negative 9/4, bracket, union, bracket, negative 1/4 to positive infinity. Okay, that's your answer. Last one. All right, we're just gonna, first thing we have to do is get this absolute value by itself on one side. You cannot do anything with this until you start simplifying this and have only the absolute value on one side. Subtract 4 from both sides. Divide both sides by 4. I'm going to go ahead and reduce this to 3/2. All right, now we can split this up. It is absolute value is greater than, so you're going to write x minus 6 is greater than 3/2, and x minus 6 is less than negative 3/2. Okay. Solving for x. We need to add 6 to both sides. So x is greater than. So depends on how you want to look at this. So if you're struggling with fractions, as I know many of you do, I want to come over here and talk about this. This is 6 plus 3/2. All right. This is 6 over 1. Anytime it's a whole number, it's over 1, right? So I need them to be the same. I need them to both be 2 so that we can add them. Or you can go around the world if you learn that. It's your call. So this is 3/2. 1 times 2 is 2, so 6 times 2 is 12. So this is 15/2. 12 plus 3 is 15, same denominator. We're going to add 6 to both sides. Same thing. 6 minus 3/2 is over 1. It's going to be 12/2 is 6. 12 minus 3 is 9/2. All right. In interval notation, so I'm going to do my graph so I see what this looks like. 15/2 is going to be larger than 9/2. So what are we doing here? X is greater than 15 halves, not equal to, and X is less than 9 halves. Negative infinity, 9 halves, not included, union, not included, 15 halves to infinity. There's your answer. Make sure and read all the notes that I gave you. I hope they're very helpful. Let me know what questions y'all have.